And so a large part of what I focused on at the beginning was how do you go from zero knowledge to simply just plugging a box in and having that box discover everything that's inside of the environment. And then also actively going out and sort of interrogating each individual device on the network to see if it speaks the protocols that you're looking for. Those techniques can be used to really find the majority of these devices. I didn't want to start with an application and then work my way down the stack. I wanted to start with the hardest problem, which was the integration piece, and then work my way up the stack. My name is Shaun Cooley. I'm the founder and CEO of Mapped.
This is Code Story, a podcast bringing you interviews with tech visionaries who share in the critical moments of what it takes to change an industry and build and lead a team that has your back. I'm your host, Noah Labhart, and today how Shaun Cooley created the platform bringing together all things within the industrial environment. All this and more on Code Story. Shaun Cooley was born and raised in LA. His mom worked at Xerox, and his dad was an auto mechanic. So needless to say, at an early age, he was pulling things apart electronically and mechanically. He's an avid snowboarder, usually shredding some snow at Mammoth Mountain, and a kite surfer. He says he is terrible at the latter, but he likes that the wind is doing most of the work for him. He also spent a ton of time on his pilot's license, but it got put on hold when he got busy professionally. At age 15, he went to work for Symantec, building internal websites, and after some time, he got the opportunity to build an Easter egg in Norton SystemWorks for Windows. All in all, he spent 18 years at Symantec before moving on to Cisco and joining the IoT side of the world. During his time at Cisco, he started to see the fragmentation of data in the industrial environment. So much so that he set out to create the business intelligence layer, sitting on top of the raw network of devices. This is the creation story of Mapped.
So Mapped is a data infrastructure platform. We bring together all the people, places, and things inside of commercial and industrial environments. And so if you think of sort of a stack inside of one of these commercial or industrial environments, you've got the devices that are doing things inside of the environments. Think of the HVAC controllers and the lighting controllers. In a manufacturing floor, you've got robotic arms and conveyor belts and other sort of process automation pieces. The sort of next layer up tends to be a network infrastructure. The network infrastructure brings those pieces together on an IP network so that they can communicate with each other. But the pieces tend to still be sort of bespoke, right? They're pieces of equipment that were installed by a system integrator at some point over the last 50 years, using whatever the latest bag of tools and techniques were. And now, the companies that own many, many buildings or many retail stores or many data centers or many factories are trying to get data across their entire environments. Even though these things are all IP connected, they tend to be from different vendors, installed by different system integrators, given different names, functioning just slightly different, right? Because the goal at the time that they were installed was to operate that environment, not to, provide a single business intelligence layer for the company. And so now that they've been IP connected, we go in and we build on top of that the data infrastructure that sits on top of that network infrastructure. And so you can think of it as the missing piece between sort of the raw network and the applications and business intelligence that you're trying to extract from your operations. During my time at Cisco, I very quickly realized that it was different from every other business at Cisco. It was probably my third or fourth conversation after I'd come into the IoT team where the customer looked at us and said, "Have any of you actually been to an oil rig?" We sort of looked around the room and nobody could say yes. And so it led to 4 years of me really just visiting any customer I could, whether it was a manufacturing floor, the roof of a building or the sub-basement of a building, going behind the scenes at an amusement park or, into an oil refinery or out on an oil rig. I just wanted to feel the pain that the customer was going through and really understand it firsthand. And those sorts of discovery trips led to a repeated pattern that I kept seeing over and over again. I would get on stage for various Cisco events and say things like, Gartner predicts that there will be 25 billion connected devices by 2025. And then the next year it would drop to 22 billion. And the next year it would drop to 20 billion. And that mix of sort of the numbers continuing to move down and to the right, plus what I was observing from customers, which was they would do a pilot in one of their environments. And that pilot would take them a year to build and deploy. And then they would go to move that pilot to the next environment, to the factory across the street or the refinery on the other side of the country. And it turns out that all the work they had done for integration, all the work they had done to sort of extract data out of those systems and bring it into the dashboards and the analytics that they were trying to put together had to be done again. It had to be done from scratch because that factory across the street or the refinery on the other side of the country had no sort of commonality with the systems that were in the first one where they built the pilot. And again, this was just a side effect of the various system integrators using whatever was the best set of tools at the time. This pain of integration plus the sort of droppings, predictions of connected devices or IoT devices really got me thinking about what is the biggest problem that we have in IoT or in digitization. And that problem is that as we try to bring together all these devices in order to come up with transformative insights, the complex relationships among the devices are where that transformative insight comes from. And to do that, you have to deeply integrate with these systems. And so if we can free up the industry from having to do all the integration manually, and we can automate the processes of doing integration and sort of reverse engineering what humans had built in the first place, then we can really sort of open this industry at scale and allow developers who maybe have never set foot on a factory or have never gone into a refinery to really start to build applications by just purely looking at data and starting to figure out ways to make sense of the data rather than spending all their time on integration.
Tell me about the MVP. Tell me about how long it took you to build that first product and what sort of tools you used to bring it to life.
I started in July of 2019. And the first thing that I started to build was an edge gateway. So a little compute box that can go into one of these environments and really discover all the things that are inside of the environment. From my security background, I had built sort of enterprise asset management or network discovery techniques in the past. And so a large part of what I focused on at the beginning was how do you go from zero knowledge to simply just plugging a box in and having that box discover everything that's inside of the environment. And doing these sorts of, passive network monitoring, where we're sort of watching packets move across the network and looking for protocols that we know how to speak, like an S7 or a OPC or, Modbus or BACnet. And then also actively going out and sort of interrogating each individual device on the network to see if it speaks the protocols that you're looking for. Those techniques can be used to really find the majority of these devices. And so, because I was trying to start from the integration side of things, I didn't want to start with an application and work my way down the stack. I wanted to start with the hardest problem, which was the integration piece, and then work my way up the stack. And so this edge gateway was really the first thing that was built. And I probably spent 7 or 8 months working on that. It was probably January or February of 2020, before I brought somebody else, this guy named Jason Coe, who had spent the prior 6 years building out as the co-creator of something called Brick Schema, which is a data ontology or a data schema that allows you to describe the various constructs inside of these spaces in a very prescriptive way. And so, I had started to build the pieces that move data out of the environment and into a cloud. And Jason had spent a lot of time thinking about, how do you describe them once they're in the cloud? And so that left this gap in the middle of a data pipeline, really the sort of things that we would bring together to really drive, all the data from one edge into the other edge. And these pieces were, the really important pieces from a scaling standpoint, right? We can put a bunch of boxes out into buildings and factories and start moving data to the cloud. But when you get to the point where you've got millions of individual bits of data moving through your data pipeline from one end to the other, and you have this target ontology, you really need to start to figure out how to scale the bits in the middle, how to shard the pieces that are in there. Unlike a lot of the rest of the world, COVID really allowed us to focus on the architecture and building out this MVP. And so, we actually spent about 18 months, if you take from sort of July of 2019 when I started until we came out of stealth in March of 2021. But we started talking to customers in sort of that January of 2021 timeframe, and so we took about 18 months really building out that MVP. And we were also lucky because there's just a lot of amazing open source and other tools that we can use along the way that I think really got us to where we are now much faster than it would have been a decade ago.
With any MVP, you have to make certain decisions and trade-offs, and I think you touched on it a little bit, but I want to dive in a little more. It could be technical debt, it could be feature cut, but what sort of decisions and trade-offs did you have to make in the short term with your MVP, and how did you cope with those decisions?
Again, if we look at the tools that were available to us at the time, right, things like Janus Graph on the graph side, or Scylla, or Pulumi allowing us to build sort of infrastructure as code. There was just a lot of things that allowed us to move very, very quickly on the technical side. What ended up happening was we ended up overly focusing on the data pipeline and the security sort of aspects of that data pipeline, and not really putting enough effort into the connectors. And so, as a data pipeline, the biggest thing you have to do is bring data into it. And so we had started with the Edge Gateway, and the Edge Gateway had, pretty good support for most of the protocols that we cared about. But, when we started to look at the larger landscape, there was a significant number of sort of cloud-first vendors playing in these spaces as well. Companies that do like badge readers or air quality monitors or vibration sensors, where those sensors are directly connected to their cloud. And so their cloud has APIs. And so I had started with this problem of how do you get data out of a physical environment? And it turns out that some of the newer sensors in there were already getting data out. They were already moving it to the cloud. And so, even though we had built out this data pipeline and had put a lot of effort into it, I think we fell short on the connectors side. And we've come back around in the last couple of months. We're at the point now where we can add a new connector in a matter of a couple of days. And so the ability to do that, I think, is really sort of changing the way that we build out the product and meet customer demand. I think the other big one for us was that as we were building the website, the customer portal where the customer comes and interacts with the product, we made a very early decision, which is a somewhat weird decision given the era and how everything else is going, but we made a very early decision to not support mobile. When you look at how facility managers or factory operators are interacting with the systems that they have in those environments, they're not doing it from a mobile device today. And that's not to say that they won't in the very near future, but the customers that we spoke to, sort of told us, look, I'll either have an iPad or I'll have a full-blown laptop or a desktop machine that I'll be interacting with. It was very, I would say, counterintuitive for us to sort of not focus on the mobile space at the beginning.
So from that point, you've got the MVP, you've made your trade-offs, you're getting some traction. How did you progress the product from there, and how did you mature it? And I think it'd be really interesting to hear how you made your roadmap and how you figured out, okay, this is the next most important thing to build.
I would say on the roadmap side, it's a mix of intuition and just talking to a lot of customers. We would get in front of pretty much anybody that we could, sort of tell them what we're up to, try to figure out what systems they have in their environment, how those systems are connected, what remote access they have into those systems, all those sorts of things that would help us really shape the backlog of protocol adapters and connectors and and other pieces along those lines. We were lucky enough, my CTO had previously built a company called Tropo, which was a competitor to Twilio. He left there and joined Twilio, and so his entire background has been in developer ecosystems and developer APIs. My chief data scientist is Jason Koh, that I talked about earlier, the co-creator of Brick Schema, which is this ontology that is very robustly defines all the sort of devices and relationships inside of these environments. And then I had spent 4.5 years visiting every customer environment I could get my hands on and talking to them in the past. And so using a mix of our backgrounds plus those conversations, the ongoing conversations with customers, we continue to shape the roadmap. We continue to find new ways to be innovative and to sort of speed the integration of these environments. The product, over the months that we've been out there with it, the things that we've been focused on are really around scalability, our ability to control uptime for the product, right? We want to make sure that if we are the data pipeline they're counting on, that our product is up and available. Again, these environments oftentimes have very sensitive data that's coming out of them. The customers are very concerned about where that data goes. There's a lot of formulas that end up in the data, inadvertently, but you want to make sure that it's secure. And similarly, you want to make sure that you're not creating a path for an attacker to get back into one of these environments, right? If they come in and attack our cloud APIs, that they can't use that to sort of leapfrog all the way back into the environment. And so, along the way, that included things like, how quickly can we deploy to new clouds? If we work with a customer, you can imagine a large retail customer may not want us to be in the Amazon cloud, right? Similarly, you may end up working with another customer that may not want us to be in the Microsoft cloud. And so how quickly can we deploy to new clouds? How quickly can we be a multi-cloud product that allows us to serve those customers and serve the needs that they have? And then I think the last one is really around new ways into buildings. And so even though I had spent a significant amount of time on the hardware and the box that goes into these buildings, it turned out that that's not always the best way to get data out of these environments. And so we started looking for ways to take the same software that was running on our edge gateway and look for new deployment mechanisms for it. Things like, either us hosting it in the cloud and VPNing into these environments if we can, or delivering a containerized experience to the customer where they can deploy it into Kubernetes or Docker or any other sort of open container image compliant platform that they have inside of their environment. And that allows us to more quickly deliver and also reduce our costs along the way to get into these environments.
Well, let's switch to team. So tell me how you built your team and tell me what you looked for in those people to indicate that they were the winning horses to join you.
When the company started in July of 2019, I very much wanted to build an LA-based tech company. The first 18 years of my career had been in LA, and the next 6 had sort of been living on airplanes. There was definitely a desire to sort of build a team around Los Angeles. COVID very quickly changed my mind on that. I think once we were all working from home, it became very easy for us to really go after the best people anywhere on the planet, rather than trying to continue to build in LA at the time. We were lucky enough that one of our early investors is also the CEO of a company called Oyster, and Oyster does this employer of record model for us to be able to hire in other countries, and makes it very easy for us to sort of hire folks in whatever country they happen to be in, and Oyster takes on all the logistics of what that means. We instead switched to trying to find the people that we could see proof that they were sort of the best in the space at what they were doing. A guy named Alex, who had been a lead contributor to something called Janus Graph, which is an open source Apache project, but is really the heart of everything we do at this point. And for anybody that's worked with graph or graph databases in the past, it's a very hard thing to scale. It's a very hard thing to customize. And so when we start looking at things like how do we do permissioning on individual edges or vertices inside of the graph, or how do we scale it, or how do we shard it, these questions all come back to Alex, and Alex's ability to really deliver on these things, is derived from the amount of time that he spent inside of all of Janus Graph. Similarly, there was an open source project called PLC4X, also an Apache project. And PLC4X is really a bunch of protocol drivers or protocol adapters for these on-prem protocols. It supports, at the time, I think it's about 10 different protocols that it has support for right now. But Chris, the lead developer for it, his understanding of sort of reading manufacturer specifications or standard body specifications on a particular protocol, and we're talking low-level wireline protocols, sometimes over serial buses, sometimes over IP. His ability to read those specs, turn it into a domain-specific language that's used for PLC4X, and then have code that generates, C# or Java or Go, is really amazing. And again, we were able to find Chris through sort of reaching out and looking at other projects that were working on pieces of the puzzle that we had been doing. I think similarly, our head designer, Erin Fenley, had previously been at Comfy, which was a company that was acquired by Siemens, and had spent, she had spent a lot of time in this space thinking about how to deliver products to the exact audience that we are delivering to. And finding her, again, she's based in Tennessee, not something that we would have found if we were just focused on Los Angeles. So I think, again, we benefited from the fact that COVID made us think differently about the way that we were going to build our team and the way that we would go and find people and bring them into the organization. And so, as we move forward, we'll continue to look remotely and continue to pick up folks, sort of the best people we can, no matter where they are in the world.
This episode is sponsored by Vanta. You're a startup founder. Finding product market fit is probably your number one priority. But to land bigger customers, you also need security compliance. And obtaining your SOC 2 or ISO 27001 certification can open those big doors. But they take time and energy pulling you away from building and shipping. And that's where Vanta comes in. Vanta is the all-in-one compliance solution helping startups like yours get audit ready and build a strong security foundation quickly and painlessly. How, you ask? Vanta automates the manual security tasks that slow you down, helping you streamline your audit. And the platform connects you with trusted vCISOs to build your program, auditors to get you through audits quickly, and a marketplace for essentials like pen testing. Join over 8,000 companies, including many Y Combinator and Techstars startups who trust Vanta. Simplify compliance and get $1,000 off at vanta.com/codestory. That's VANTA.com/codestory. This episode is sponsored by Kinsta. Between juggling client meetings, managing your website, and keeping up with everyday tasks, who has the time to stress out about website security? Well, with Kinsta, the technical stuff is taken care of, so you can focus on what you do best. Kinsta provides managed hosting for WordPress, offering lightning-fast load times, top-tier security, and unmatched human-only customer support. Whether you're a business owner, web developer, or running a digital agency, Kinsta makes managing your website easy and efficient. Kinsta provides enterprise-grade security, being one of the few hosting providers for WordPress with SOC 2 and other certifications, guaranteeing the highest level of security for your website. Thanks to their unlimited free expert-led migrations, Kinsta ensures a smooth transition for you from other hosting providers. Customers have reported 200% faster load times post-migration to their platform. What I find cool about Kinsta is their fast and reliable customer service and premium features that are included at no extra cost. Ready to experience Kinsta's hosting for yourself? Get your first month free when you sign up at kinsta.com today. That's KINSTA.com. Well, let's talk about scalability. So did you build this to scale efficiently from day one, or are you fighting this as you grew?
Scalability is always a work in progress. We're always looking for new ways to shard data, to push out workloads to different locations to find things that we can do in here. We're very lucky to have Jose De Castro, who's our CTO, having built a real-time communications company, dealing in phone calls and text messages that had to happen, very scalably at a broad range of systems, who had built that Tropo company that was acquired by Cisco, and now is thinking through how we scale things out. Jose, between Jose's experience and my time, sort of 25 years building enterprise and large scale consumer applications, I think that it's always been top of mind. We're always thinking about what is going to be the bottleneck. How do we make that piece not the bottleneck? And again, I think we're all living in a very lucky time where companies are publicly describing how they do scalability. And so, for example, in our graph, we took a lot of sort of techniques from Uber, who also scales, very largely across the entire world. Probably one of the biggest graphs that exists out there, between vehicles and passengers and drivers and all the other pieces that are in there. And Uber had built something called H3, which is a partitioning scheme for graph database that is based on geospatial constructs. And so it sort of splits the Earth up into these hexagonals, and then each hexagonal can further be split up into more and more hexagonals. And so what it means is that when we pull data out of a building or pull data out of a factory, we can control the size of the hexagonal of the shard or the partition that's being used in that particular instance. And so, if you look at somewhere like LA, where there could be a bunch of buildings on the platform, we would break it up into very small sort of portions of space, meaning that there'd only be maybe 2 or 3 or 5 buildings inside of that space. And then if you look at somewhere like an Iowa, maybe we can cover the entire state with one partition, because the amount of data that's coming into it is drastically less. And so these sorts of techniques, would have taken us many, many years to come up on our own. But because other companies have been so, sort of outward facing around some of their architectures and some of the techniques that they use to achieve these scales, we've got a lot of good pieces we can pull from to sort of, speed up our ability to scale and to get to a point where we can handle, hundreds of millions of data points, pushing data into our platform every single second.
Well, as you step out on the balcony and you look across all you've built with Mapped, what are you most proud of?
The thing that I'm most proud of right now is our team. We, for a 13-person team, have built an amazing platform. And as we build out the team, we will continue to have very high standards for the people that we bring into the company. And it's going to be just I think an incredible growth as we add to it. The other pieces are, look, from an architectural standpoint, we built something that we call Mapped in a Box. And Mapped in a Box is our entire stack. It's all, sort of 100 services and microservices and, APIs and databases and other things that would normally be stood up in a cloud, but it can run on a local machine. And so it allows our developers, some of which are on Windows, some are on Mac, some are running Linux boxes, to very quickly run a local instance of our entire stack, and really, very quickly build new functionality or troubleshoot things that aren't working quite right. And then, that same exact stack moves into a data center, right? It moves into an Azure cloud or an AWS cloud. And this ability for us to very quickly go from a laptop scale to a full cloud deployment scale, I think is one of the best decisions that we made early on, and has allowed us to move very, very quickly.
Well, let's flip the script a little bit. Tell me about a mistake you made and how you and your team responded to it.
There's 2 mistakes that come to mind over the time we were building that initial MVP. The 2 types of sort of graph databases that are out there, one of them is called RDF, or Resource Description Framework. Some people call it a triple store as well. And then the other type is really a labeled property graph. The brick schema piece that we started with was really built for RDF. It was built with this, W3C RDF concept in mind. And we went pretty far down the path of an RDF database before we realized that it just doesn't scale. At least it doesn't scale to the scale that we're looking for. At the point where if we get as far as we want and we've got every building on the planet into our platform, there was zero chance that an RDF graph was going to scale for us. And so I think that when we hit that realization, we were already pretty far down the line with RDF, and going back, re-implementing our queries, re-implementing the way that we do permissioning and access control. Re-implementing the way that we do sharding and the way that we scale the really the heart of our entire product was a big hit to the team, and I think the team took it quite well. I think everyone had sort of started to see the writing on the wall, and so it was it wasn't a shock when it came when we had to make that decision, but it was definitely we had to throw away something that we had been working on pretty hard for many months. I think the other one for us is we started out with with sort of a function based cloud. We were going to do these, Azure calls them functions, AWS calls them lambdas. But really, when we get down to it and you start trying to operationalize and automate the deployment of these functions, we hit a wall. It wasn't easy for us to do infrastructure as code, in Pulumi or Terraform that would allow us to very quickly deploy these functions. And so we made a very very late decision. It was probably halfway, a little more than halfway through the process, to sort of abandon the function-based deployments and switch over to a Kubernetes-based deployment. And so, our microservice framework was sort of born out of our switch from Azure Functions into Kubernetes. And again, we benefited from there's an open source project out there called Temporal that again spun out of Uber. It used to be called I think Cadence when it was inside of Uber. But we took Temporal and we built this gRPC based framework around it that allowed us to both use Temporal and the sort of scheduling and workflow type processes that were in there, but also access it through gRPC, an RPC based, I should say, remote procedure call based mechanism that's on our sort of inside of our cloud. And so what we got out of that was significantly more flexibility, significantly more sort of scale and speed. And I think that, again, it was a very tough decision at the time, but the team responded fantastically and was great about shedding what was very quickly turning into very heavy technical debt, and turning it into an opportunity to sort of take the learnings that we had and apply it to a new mechanism that would scale with us much longer into the future.
So, what does the future look like for your product and for your team?
On the product side, the pieces that we're really looking at, our mission in life is to, expand the pool of developers that would otherwise not be able to target these very complex environments. Today, if you want to walk into a Ford factory or a Chevron refinery, or a building that's run by Boston Properties, you need some pretty hefty credentials to be able to do that. You need a product that has sort of proven itself in other environments, right? Which means that you've always got this catch-22 of how you get into one so that you can scale into others. And our mission is to really take all the load of figuring out how to integrate with those environments and moving it up to a cloud API. So that when a developer, think of a nights and weekends developer that's just trying to build something on the side that they want to think of, that's in their mind, that they can go and try and sell it to a Boston Properties or to a Chevron or to a Ford, because they don't actually need to set foot on the factory floor or in the refinery in order to finally make that sale, right? If we can change this environment so that rather than heavy sales and heavy integration teams and big sort of developer bases that are needed to do these things, that it can be a single developer working nights and weekends building a product that eventually lands into a marketplace of sorts, where they can get the attention of those big companies and through a purely cloud API show value to those companies. I think that expanding that pool of developers really gets us into a much better world, a world where again, people are focusing on the innovations and the value they want to bring rather than the headaches of integration that they have to do today. And I think that eventually leads to what we call third and fourth party. And so, sort of fourth party is probably not the best term, but a data exchange type world, where application developers in the third party sense, or eventually, even the sort of completely disconnected data consumers. You can imagine that a first responder, showing up to a 100-story building, walking in, and just based on the fact that they're within the sort of the premises, that their mobile device is able to communicate with a cloud API that can show them where people are inside of the space, where the fire is, where the alarm is, which elevators are still working, which ones have been shut down, which stairwells, give them floor plans. Those sorts of pieces of information, I think, come from the ability to normalize the data and expose it through an API that then allows these other applications to make use of the data without, today, if you walked into a building and you tried to do that, it would require hundreds of connectors. It would require all sorts of manual integration to happen in advance. And I think we can get to a smarter everything world, where everyone just uses this sort of brick schema, this communication model and API that allows them to understand the people, places, and things around them, and do it in a way where we don't have to focus on the integration or the vendors that were involved in the sort of first steps of it.
So let's switch to you, Shaun. Who influences the way that you work? Maybe a CEO, a CTO, an architect, a person, really any person. Name a person that you look up to and why.
That's a tough question. There's so many people I can think of. The first one that comes to mind is Rowan Trollope. Rowan is the CEO of Five9, which is a contact center in the cloud, right? When you call Delta and it has all the agents that answer the phone, like Five9 is the one that runs that contact center. The reason that I look up to Rowan so much is when I started at Symantec, Rowan was in the cube next to me. He was a software engineer at the time, and so Rowan and I have gone through a very similar progression. Rowan, many years ahead of me on the progression, but I think I've learned a significant amount from watching Rowan and watching the way that he tells stories to unite teams and to sort of paint the picture of the vision for his company. Whether it was Symantec at the time or Cisco or eventually Five9. But that progression of how do you go from a very, very technical, sort of heads down software engineer to leading a large organization and convincing the world to come along with your vision. And I think that he does it better than pretty much anyone else I've seen out there. And so I take a lot of inspiration, a lot of cues from the things that he does.
Well, we talked about mistakes, right? But a little bit different spin. If you could go back to the beginning, what would you do differently? Or where would you consider taking a different approach?
It's tough with a data platform, right? When you're looking at building a platform, building APIs, like there is no easy path to a smaller version. But I think, if I could go back, I probably would have started much, much smaller, right? Started with one or two connectors, started with a platform that maybe didn't scale quite as much, but something that we could have gotten out into the market in a month or two, and then iterated as fast as we possibly could on it, right? I think that this is do less, listen more, get out to the customers, sell things faster, understand more deeply what's working, what's not. We're in a very good place right now. I think the platform we've managed to build something that is robust and scalable. But I think that we missed out on many months, if not a year or more, of early customer feedback on that could have shaped our product and really driven us, I think, to revenue much more quickly than we achieved. But it's sort of the ship has sailed. I think that again we've built something amazing, and I think that we'll do just fine with it. But definitely would have started smaller and iterated faster. And again, having come out of 25 years of Symantec or Cisco backing me on most things that I did, it was definitely a mind shift, right? Because in my head, at a Symantec or Cisco, there is no start small, right? You start with the big grand vision and build it out. And I think that, being a first-time founder, I fell into that trap. And luckily, I think, had enough backing from VCs and customers that we did find that we managed to climb out of that trap and end up with something really nice. But definitely fell into that trap as a first-time founder.
Well, last question, Shaun. So you're getting on a plane and you're sitting next to a young entrepreneur who's built the next big thing. They're jazzed about it. They can't wait to show it off to the world. Can't wait to show it off to you right there on the plane. What advice do you give that person, having gone down this road a bit?
The advice is very similar to what I just said was our, sort of, if I could go back, what I would do differently, which is make sure that you get something in front of customers as early and as often as possible. I think it's very easy for an entrepreneur to fall in love with the thing that they've built. And it is easy to carry on down that path for a very long time before you're willing to sort of show it to somebody else and truly open yourself up to feedback. And it's something that everyone has to fight when they're building something from the ground up, because the sooner you get feedback, the sooner you can pivot, the sooner you can change direction, even if just slightly, to make your product more appealing to customers, to make the customers happier about the things that you're building, and really bringing them along for the ride. There's a lot of value, especially in enterprise software, when the customer feels like they've contributed to the roadmap in a meaningful way, and the customer can see the product sort of shift and adjust based on the feedback that they're giving. That has a lot of power in making the customer feel like they're a partial owner of the thing that's being built, and really helping to drive that value back to them, which keeps them along as a customer. And so I think the feedback would be very similar to what I just said, right? Which is just get it out there early, get it in front of customers often, iterate as quickly as you can on the feedback that you receive. That's
great advice. Well, Shaun, thank you for being on Code Story. Thank you for telling the creation story of Mapped.
Yeah, thank you for having me.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. Support the show on patreon.com/codestory for just $5 to $10 a month. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.
You just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. Stop struggling to get your job post seen on other job sites. With Indeed sponsored jobs, your post jumps to the top of the page for your relevant candidates, so you can reach the people you want faster. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Don't wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ13. Just go to Indeed.com/PODKATZ13 right now and support our show by saying you heard about Indeed on this podcast. Terms and conditions apply. Hiring? Indeed is all you need.